Good day, everyone. I am Luis Grace Avena, and I will be discussing a topic that is relevant to physical chemistry, and that is the partial molar quantities. So, our main objective for our discussion today is for you to be able to define partial molar quantity and for you to be able to understand or have a good understanding of the relevance of the partial molar quantities in a specific thermodynamic system. So what is partial molar quantity? Partial molar quantity is only essential when you are dealing with a thermodynamic system that contains at least two substances. So in that sense, you are dealing with a mixture or a solution with two or more components. And it is relevant to be understood because partial molar quantities indicates how an extensive thermodynamic property changes with any variation or change in the molar composition of the components of a mixture or solution while the temperature and pressure are held constant. Because in an open system, any extensive thermodynamic property M is a function of temperature, pressure, and molar compositions of components 1, component 2, up to the ith component. And from this, we could define that the partial molar quantity of the ith component of any thermodynamic property M is actually the partial derivative of quantity Nm with respect to the molar composition of the ith component at constant temperature, pressure, and molar composition of all other components up to the jth component wherein J is not equal to I. So if you have any questions at any point in our discussion, feel free to type it in our chat box and I will try to answer everything at the end of our discussion. So as I've said earlier, the extensive thermodynamic property M is a function of these properties. So any change in the total molar quantity of any extensive thermodynamic property M is brought about by or contributed by the changes in temperature, pressure, and molar compositions of all the components in the system. And if we hold the temperature and the pressure constant, then these first two terms will be canceled out because there will be no change in temperature and no change in pressure. So essentially, at this point, wherein the temperature and pressure are constant, the contribution of the changes in the molar compositions of all the components are the only contributions that are relevant to the changes in the total molar quantity of an extensive thermodynamic property N. So from this equation, we could actually derive an expression to solve for the total molar quantity of any extensive thermodynamic property as a function of its corresponding partial molar quantity. So any extensive thermodynamic property M is equal to the summation of its corresponding partial molar quantity multiplied by the molar fraction xi for all components. And these two equations here are true for all extensive thermodynamic properties such as internal energy, volume, enthalpy, entropy, Gibbs free energy, and Helmholtz free energy. So the total molar quantity of all the thermodynamic properties indicated here are all functions of their respective partial molar quantity. So why is it important for us to understand or have a good grasp of the partial molar quantities in thermodynamics or in physical chemistry? It is because if we are going or if you're going to experiment with or you're going to study an open system that initially has component A, so initially you have moles of A, and you intend to add later on component B, so you are adding component B. Initially, you would think that as you add moles of B or as you add component B to the system, the total volume of the system will be increasing. But that is not true or that is not the case in real real experiments or real solutions because at some point the volume or the total volume of the mixture or solution tend to decrease. And this is because partial molar quantities or partial molar volume are being accounted for. So let's say, for example, you have a system, and your system is composed of component A, which is water, and component B, which is ethanol. And you have 1 mole of water and 1 mole of ethanol. And you are curious of what the total volume of your mixture or solution is. So if you're going to disregard the partial molar quantity or the partial molar volumes of each components in your solution, then you would think that the total volume is just equal to the sum of the partial molar volume of pure water plus the partial molar volume of pure ethanol, which is 18 and 58 centimeter cube per mole respectively. So the total volume would be 18 centimeter cube per mole times 1 mole of water plus 58 centimeter cube per mole times 1 mole of ethanol. And you would arrive at a value of 76 centimeter cube of solution. And again, you would only arrive at this value if you're going to disregard the molar contributions of each components in your system. So in that sense, you are going to disregard the partial molar volumes of each component. But if we are going to take into consideration the partial molar volumes of each component at this concentration, whereas the molar fraction of ethanol XB is equal to 0.5 because 1 mole of ethanol over 1 mole of water plus 1 mole of ethanol is equal to 0.5. So in our diagram here, at point 0.5, the molar volume of water is actually at around 17 centimeter cube per mole only, and the molar volume of ethanol is at around 57 centimeter cube per mole. So with those information, VA is equal to 17 centimeter cube per mole, and VB, or partial molar volume of B, is equal to 57 centimeter cube per mole. Then our total volume would be 17 centimeter cube per mole times 1 mole of water plus 57 centimeter cube per mole times 1 mole of ethanol, and the total volume is only 74 centimeter cube, which is quite less than what we have computed earlier when we have disregarded the molar contributions of each component. So what we are trying to say here is that any extensive thermodynamic properties such as volume, enthalpy, internal energy, Gibbs free energy, Helmholtz free energy, and entropy are very much dependent on the contributions of the molar concentrations of each component. So if you have any questions regarding this, again, you can type it in your chat box, or you could email me at my email address, which I will show later. So actually, after this point, we will be having an example for computing the partial molar volume of a specific binary solution and computing for the partial molar enthalpy of a specific binary mixture. But I will be cutting our lecture at this point. So if you have any question, you could just email me at my email address and I will try to answer them immediately. So again, thank you for listening, and I hope I have given you valuable insights about partial molar quantities. See you on our next lecture.